This YouTube is about momentum. The momentum of a single mass m with velocity v is simply the product of its mass and its velocity. So if its velocity is pointing in a certain direction, its momentum will be pointing in that same direction. And to say it differently, velocity and momentum of a single particle are parallel to each other. The units for momentum are kilograms meters per second. For example, if you have a mass of 2 kilograms and a v of 3 meters per second in the x direction, then the momentum would be a vector of 6 kilogram meters per second in the x direction, positive x direction. If we have two masses, m1 and m2, each mass has a momentum associated with it, and it's defined as m1 v1 for mass 1, and that gives this vector p1, and m2 v2 for mass 2, and that gives this vector p2. It should be a 2 there. So what we're going to see later is that the total momentum is something we want to keep our eye on. And so if you have more than one momentum vector, because you have more than one particle, and each particle has its own momentum, then we can define a total momentum for the system, which is equal to the sum of the momenta of each one of the two particles. And so with the example that I have right here, here's P1, here's P2, and P1 plus P2 is this Fred vector right there. Numerical example, this is a graphical example here. Let's say we had a 2 kilogram mass going at 1 meter per second in the positive x direction. So the momentum vector associated with m1 would be 2 kilogram meters per second in the positive x direction. And let's say m2 was 1.5 kilogram mass, and it had a 2 meter per second velocity in the positive y direction. Well, then its momentum, the momentum for particle 2, would be 3 kilogram meters per second in the positive y direction. And then if we added those two together, and I can see that there's a typo here, so let's fix it. I want P2 to be in the positive direction. So that would give me a vector P2 that looks like this, and the sum would be this vector I'm about to draw, like this. P1 plus P2 is this vector right here, and P1 is that vector right there. So nothing new about adding vectors. You can use the tip to tail technique, which is what I usually do in class. But as I said, we're going to see that the total momentum is something to pay attention to. We're going to find in certain situations it's conserved, and so we want to know how to compute it. Third example I have here is a swarm of bees buzzing around a flower. Let's say they're just about to get to a flower and they're all buzzing around it, and each bee is going in some different direction. They all have different masses, and if there's a bunch of bees here, and if you add all their momentum vectors together, the momentum vectors are going to be roughly 0 kilogram meters per second, because on the average there's just as much momentum in in the plus x as there is in the minus x direction, in the plus y as there is in the minus y direction, and in the plus z, that would be in or out of the plane, as in the minus c direction.